Bismillahirrahmanirrahim. Assalamualaikum and very good day to all my name is Shaliza. Our lecturer teaching us CHM256. Today, I and my group will present the application of chromatography in analysis of benzoic acid and tartrazine in soft drinks. First of all, I will introduce my group members. This is Timothy Martis and Kennedy, our leader here, and me, Arif Lukman bin Muhammad Hassan, and our friend Muhammad Rafi bin Hazairi. So we jump into what is chromatography. In chemical analysis, chromatography is a laboratory technique for separation of a mixture into its components. The mixture is dissolved in a fluid solvent called the mobile phase, which carries it through a system on which a material called the stationary phase is fixed. So basically, chromatography is a technique that we use in a lab to spread and analyze components in mixture. In a mixture, it works by passing the mixture through a medium where different substances move at different rates, allowing them to be isolated and identified. So to know more about the chromatography, we have to understand the principle behind it. So the principle is different components in a mixture have varying affinities for stationary phase, causing them to move at different speeds and spread. So chromatography is based on the differential distribution of components between two phases that we have learned, a stationary phase and a mobile phase. As the mixture moves with the mobile phase through the stationary phase, components spread based on their differing affinities or interaction with these phases, leading to their isolation and identification. So that we can understand what we can understand to understand more deeply into this chromatography concept.
Hi, my name is Muhammad Rafiq. I will talk about some key terms in chromatography. One of the central components of any chromatography system is the stationary phase. The stationary phase is the part of the system that does not move. It remains fixed in place while the other components such as solvent and analyze reverberate. Secondly, mobile phase is the part of chromatography system that moves. It carries the mixture of analyze through the stationary phase. The mobile phase can be a gas, a liquid, or a supercritical fluid. Next is about elution, eluent, and eluate. For elution is process in which solids are washed through a stationary phase by the movement of the mobile phase. Eluent is the solvent used to carry the component of a mixture through a stationary phase, and eluate the mobile phase that exit the column. In partition chromatography, separation is based on solid partitioning between two liquid phases. Analytes with higher solubility in the stationary phase move more slowly, while those with higher solubility in the mobile phase move faster. This differential movement results in the separation of the analytes. For absorption chromatography, the stationary phase is solid. The separation of components occurs through a series of absorption and desorption steps. And lastly, for me, the type of chromatography. For planar chromatography, it has stationary phase is a spot on a flat plate on in the pores of a paper. For example, paper chromatography, thin layer chromatography. Next is column chromatography. Stationary phase is held in a narrow tube. Mobile phase is forced through the tube under pressure or by gravity. That's all from me. Continue with Timothy.
For the next part, I'm going to present about the application of basic chromatography, which is the analysis of benzoic acid and tartrazine in the soft drinks. This part may include theory, methodology, and example of result. First of all, as we know that natural and artificial food additives have been used for centuries to preserve the food quality, such as the taste and appearance. For example, food was preserved using different technologies such as pickling or salting. But nowadays, food production companies are using different types of of range of additive, which is more than 2,500 types of additive in order to preserve the quality of their products and to meet the customer desires. In this study, we're gonna look through food additive and preservatives, which is benzoic acid and tartrazine. Benzoic acid is a common preservative that prevents microbial growth, while tartrazine is a synthetic yellow dye used to enhance the visual appeal of beverage. In the food industry, chromatography ensures that products are safe for consumption and meet the regulatory standards. For example, it helps in detecting preservatives like benzoic acid and colorants like tartrazine in the soft drinks. Next is the methodology. First, material, which is TLC plates, silica gel plates, and then extract of the soft drink, and then solution of pure benzoic acid and tartrazine, ethanol, capillary tubes, and micropipettes, developing chamber, UV lamp, iodine chamber, and dehydrin spray, and also pencil and ruler. Next, Next is the procedure. First of all, preparation of the TLC plate. Prepare two TLC plate and then using a pencil, draw a light line about 1.5 cm from the bottom of the TLC plate for each, and then mark evenly spaced point along this line for the sample and the standards. Second is the application of extract to the TLC plate. For the first plate, which is apply a small amount of benzoic acid standard solution by using a capillary tube to the point on the baseline. And then second TLC plate, repeat the same procedure as the step 1 for benzoic acid for the tartrazine. And then for the example, apply the extract of the soft drink to its designated spot on the baseline, again trying between application if spotting multiple times. For the next part, which is the development of the plate. First, preparing the developing chamber for benzoic acid, pour the ethanol solvent into the chamber and then saturate the chamber by closing it for a few minutes. Second, the developing the plate for benzoic acid, place the TLC plate in the chamber and then make sure the baseline is above the solvent level. Allow the solvent to ascend until it is about 1 cm from the top. Remove and mark the solvent front. Third, preparing the developing chamber for the tartrazine, and then pour the butanol acid solvent into another chamber and then make sure to saturate the chamber similarly. Fourth, developing the plate for tartrazine. Develop the TLC plate for tartrazine using the same procedure as the benzoic acid. Lastly, which is the trying and visualization. First, when the solvent front has reached 3/4 of the length of the plate, mark the position of the solvent front and then remove the TLC plate from the chamber, and then allow both plates to air dry completely. For benzoic acid, make sure to place the plate under UV lamp. Benzoic acid spot will fluoresce under the UV light. For the tartrazine, place the plate in an iodine chamber or spray with hydrogen. For the last part, which is the example of the result of the TLC analysis. The formula to calculate the RF value can be done by distance traveled by the spot divided by distance traveled by the solvent front. For example, if the benzoic acid spot traveled 2.5 cm and the solvent front traveled 5 cm, the RF value is 0.5. Comparing this with the standard confirms the presence of the benzoic acid in our TLC plate, which can be also applied to the RF value for the tartrazine and can be calculated and compared with its standard. Matching RF values and spot appearances confirm the presence and the quantity of the substances in our TLC plate. I think that's all from me. Thank you.
So we end up our presentation with the conclusion. Chromatography is highly effective for analyzing benzoic acid and tartrazine in soft drinks. It enables precise separation and quantification of this compound, ensuring product safety and compliance with regulatory standards. This technique provides a reliable results, aiding in quality control and ensuring the beverages meet health guidelines. Thank you. That's all for our presentation.